Okay? Now, let's go ahead to lesson 2. Lesson 2 is May the Forces Be With You. If lesson 1 was first flight, lesson 2 is May the Forces Be With You. And the lessons after that are lift, what is drag, thrust, and stability. Those are all forces on the airplane or issues to the science of flight. When it's the stability, it starts to transition to more the engineering side. And after that, it's aspect ratio, wing loading, power loading, airplane design. Don't worry if you don't know anything about wing loading or power loading aspect ratio. We'll get you there. But on the second lesson, we talk about forces. And again, we're here to teach kids engineering and STEM. In fact, Brian Norwood just asked a question. Hey, what age group? I've used this with high school kids. I teach both middle school and high school kids. I think it depends on what math you have and what their background. We have done this. We have an elementary version that's really for 4th or 5th graders. I'm not sure much below 4th or 5th how much they'd get out of it. As we get with the high school kids, we're bringing more lessons on that will even go into greater detail. I don't know if that answers your question, Brian, but middle schoolers are capable of doing this, in case you're wondering on that. All right? And I would say the math and gets stronger, the greater, there's more math being done as you get into the engineering side of this. Pardon me. But since we are trying to teach science topics and the engineering method as part of this, okay, what I wanted to say, and I'm just checking my time here real quick, that here's a great time to teach forces. So we're teaching with kids what the concept of a force is. They probably have heard it in the past, but now's the time to reinforce it. And, we keep it simple. It's a push or a pull. We talk about the difference between mass and weight. It'd be very easy to supplement a conversation about inertia right now here if you wanted to. And so what we're going to do when we fly this, we're going to be talking about weight and takeoff distance. So as we get into that, there's a video you can watch. We talk about weight and takeoff distances and the differences. By the way, there's a very cool feature. You can fly on Mars in X-plane or on the moon, and that's what we're going to do later. But for right now, we're going to go back to quick flight and setup. So I'm going to go to settings. I'm going to go to quick flight setup. I'm going to take a little more time on these menu choices so everybody can see it. Here it is. We're back because we are at Lowry, but let's pretend Lowry wasn't there and some young person has got themselves in Ingleside. And you're thinking, well, where is this? You come up and all of a sudden you come in the classroom and there that is. Remember, just go to settings, quick flight setup, and this is in their handout. So there's no reason they can't find Lowry there. You make sure you got your Cessna again. We're going to make it 8 in the morning. We're going to make sure the air is clean. CAVA, okay, so we're set to go. This is what we've been doing. And actually, I just changed it, so let's change. What did I just do there? Let's go to this airport. I'll bring it up here in a minute. There we go. I hadn't gone back to that airport, and that's why I did that. All right. Now, the next thing we're going to do is something new you haven't done before, and that's what I want you to see now. Okay? And actually, we got another question. Okay. I'll get to, someone just asked how we can keep girls interested in this. I'll give you some tips on that. And it's interesting you bring that up because we're teaching a girls class right now. They were just so excited about it. All right, but let's get to this right now and then I'll address those questions at the end. All right, you're going to go into data input and output. Let me show you that screen one more time just so it gets plenty of time. Go settings, data input and output. Pardon me, I keep coughing. Are okay? Now, with the data input and output, you can see it says data set, data C, and flight test. All right? There's all kinds of information you can take off here. We're not going to use most of it, but this gives you a sense that this is not a toy. Boeing uses this, Gulfstream uses this, other aircraft vendors use this for proof of concept. Now they'll develop their own private in-house flight simulator once they get to the really the bolts, nuts and bolts of the thing. But as they're coming up with ideas on how they might do something, they'll test out proof of concepts using X-Plane. So your kids really are getting to use a real engineering tool here. But what we want to do is we want to be able to show it on the cockpit. So you see that cockpit display? We want it to show up there. That graphical, we're going to be able to graph it. We want that display. Saving it to disk, we don't really need to do that. We don't really need to save it to internet. As far as what we want to see, well, on the handout, it's going to say speed. Then it's going to ask distance traveled, which is number 21 here. And then finally, and this might take the kids a little bit, vertical gear forces. What we're doing there is we're going to see what kind of load is on that landing gear. And if you're teaching a little Newtonian physics at your school, or at least introducing them to concepts of that, that's you can add in there. We don't have it in the lesson plan because most 7th grades aren't going in that, or middle schools. But you could certainly add that in there if you wanted. Now, I'm going to jump back and look up at the screen of the cockpit now. There's my true airspeed, indicated airspeed, distance traveled right there at distance, and landing gear. There is some wind, so that load on the landing gear is actually changing. So that's why it's trembling there a little bit. Okay? Now, from an aviation term, true and indicated. From true and indicated, what I want you to get out of that is that we use true for this. Indicated is on an airplane, which you're really traveling, you also have the wind blowing against the plane, and it can impact your airspeed, and there's some other ways it can too. So just with the kids, they're going to use true airspeed. All right? Now we have this ability to start collecting data. The next thing we're going to do is we're going to go to aircraft, we're going to go weight and fuel. The default setting's 298. We're going to be changing this. The reason we want to make sure and look at this is if a class before yours does this lab and they start changing this weight, this payload weight, you want to make sure it's set back to 298. Okay? Now, they're going to go ahead and they're going to fly again with this weight. And then they're going to see, the goal here is to fly with this weight and then see how much distance we've traveled. Okay? So, I will like to show you one other feature in here. If your kid's struggling with taking off, if you go to about, we actually have it so the AI, the computer, will take off. We also actually have it so it'll land for them too. So that's a little something if they struggle in a little bit. We're not worried necessarily they're going to get, and they shouldn't. I'd be suspicious of the data if when they practice landing, they get the same values each time, but we're just looking for big trends. If you go to page 11 in this, in the test piloting, you're going to see we're going to take off 3 times with a payload of 298. We're going to change that payload, and let me just bring that back up again. Under aircraft, weight and fuel, we're going to change that from 298, which is this here. We can just grab this and change it to 600. So I'll drag it across after. And then we'll do it again. Bring it 600. And folks, just be close to 600. You're probably going to get to 602. You may not even get to 298, 600. But don't spend a lot of time. You just want to be close. And then the last one's 900 pounds. So that's how we're moving it to get to close to 900. All right, I'm going to go back close to 298. If I get to 300, it's fine. Just want to be close. There, I'm at 299. Okay, so now I'm at 298, same distance. Let's go ahead. We're going to remember how to take off. We hit pause, turn off the brakes, pushing the throttle. This should be just like we've been doing. I'm going to hit pause, unpause. And we're going to start creeping down the runway. If they're taking off, now it's important to try to keep them so they take off the same way every time. What I encourage the kids to do is try to keep their pointer right on that cursor, and sooner or later this plane will take off. We're going to get into lift in future lessons. You'll see why it takes a little bit longer, because our angle of attack here is pretty neutral. And you can put it right, if you want, right at the bottom of that cursor, and it'll take off once we get up to speed. I think we're taking off. Pause it. Boom. And let's look outside. We're off the ground. So again, if I hit A, it's going to show me that view. We could have looked at our altimeter, but what we look up here is look at our landing gear. It's all 0 now. Our landing gear is all 0. There's no load on the landing gear, and that's how we're going to define takeoff. But this is just a snapshot. We've already taken off. How can we collect data off this? Well, we go back up to settings, data input and output, and we go to data C. And there it is. Now that's where we're sitting on the runway. Let's go ahead. Let me back up to the very beginning. All right, we're going to turn off. If you take your mouse, you can turn off these. We don't need all these lines. So we're going to just keep V true up here. And we're going to use white V true. Get rid of that down there. We'll get rid of all these. We don't even need these. We're going to be at distance. So now my true airspeed right there is right there on that white line. You're going to see in a minute, but it's sitting still, so there's no airspeed at that point in the beginning when we first started to take off, right? There's no distance traveled. Look at the loads on the landing gear. Now as I go over across here, because I was busy explaining, it sat on the runway for a bit, so let's let it go. Normally the kids would not have that problem. So here we go. As they're going down the runway, look what your load on your landing gear is doing. It's starting to go down. So there it is. We're coming to this point. Right at this point, the landing gear is 0. Look at the orange. That says the distance traveled. Look at the true airspeed. That's a notch. You could have made true airspeed in miles per hour. It's just as long as the units are consistent, that's all that matters. So at this point, the landing gear is still, the plane is still, two of the wheels are touching. You get to this point, it's no longer touching. That's how we're going to define takeoff on this. And that's how you can collect data. Again, let me stress, it's important that they try to take off, same way every time. They have it full throttle. They point the arrow, their cursor right on that cross, right on the bottom of the cross, and so they can take off. If they pull the mouse down or add you're going to learn about is more angle of attack, it'll take off sooner. Sometimes it's better to let the computer take off. And you can do all the labs letting the computer take off and then let the kids practice. This is totally on your style.